some basic weather forecasting and also understanding how different types of air pressure and different types of air temperatures help create the resulting weather that we see on a day-to-day basis. Now, I showed you all of this on Monday and Tuesday, which was the 7-day forecast for Stowe, Vermont. A couple things I want to highlight. Over the next couple days, we should see an increase in air pressure. We'll talk more about that later on. We should also see a dramatic change in wind speed where winds go from very high to a bit lower. We should also see daily temperatures rising with a smaller chance of precipitation. How do scientists make those forecasts? And how does the atmosphere create the conditions for either snow showers, as we're having right now, compared to sunny, bright skies? So the first thing that you're going to be learning about today is air pressure. Now, when you think about air pressure, think about squeezing toothpaste onto your toothbrush. Air is a fluid like toothpaste, and it's always going to move from regions of high pressure, you squeezing on the toothpaste bottle, to low pressure, your toothbrush. Now, in terms of how air flows in our atmosphere, there's two things you want to think about: the top-down view and also the up-down view. So when we talk about low and high pressure from the up-down model, high pressure tends to have air move away from high pressure and into low pressure. When we talk about air in our atmosphere from the ground to the atmosphere, high pressure usually falls down from the atmosphere, while low pressure rises. You can watch more in this video to see how heavy air is and how pressure changes the movement of air. There's also a couple websites here to help you better understand the difference between high and low pressure. And we see this in our everyday lives. So right now you're all exhaling and inhaling. That's resulting from low and high pressure with your diaphragm contracting. Steam rising from a boiling tea kettle has a lower density and a higher temperature, so it's able to float seemingly above the air that surrounds the tea kettle. You go to clean your room, maybe. You use a vacuum, which creates a low pressure to suck dust and whatever's on your floor into the vacuum. You want to pump your bike up, you have to exert pressure and force to make your tires have a higher pressure than the resulting atmosphere, resulting in a nice tire that can go fast wherever you want to bike. So what does high and low pressure mean for our atmosphere? Think about balloons. Maybe you have a birthday party or you want to create your next getaway. We can think of balloons as air pressure. If you heat your balloon up, it will expand, and if you fill your balloon with a lighter gas such as helium, either of those conditions will make the balloon, rise up into the air. Now, as soon as your balloon gets cold, or maybe you fill it with some heavier gas like nitrogen or oxygen, which you generally don't do for birthday parties, the balloons will seemingly fall to the ground. And that's true for air masses in our atmosphere. Low pressure and hot gases tend to rise, and high pressure and heavier gases tend to fall. But what drives this on Earth's atmosphere? It all comes back to the fact that Earth is a sphere with a tilt, which means that it gets unequal amounts of solar radiation at any given time. So Florida gets more concentrated sunlight than a place such as, I'm going to say this is South and North Dakota. What this means is that regions with higher amounts of sunlight will have warmer air, which will result in lower pressure, and that air will generally rise. And as that air rises into the atmosphere many, many, many miles up, it will cool and condense, and eventually it will become denser and start to fall down. And this is a cycle that happens all over the world, where low pressure areas have air flow into and out, and high pressure systems have air fall and away. So the low pressure systems suck air in and move them up into the atmosphere. High pressure systems have air fall down and away. And this has to do with unequal amounts of sunlight. Now this creates a series of different atmospheric cells that we'll learn more about as we continue our climate and weather unit. But the general idea is that it creates very different types of high and low pressure systems throughout the Earth with very different types of weather patterns. So if you're near the equator, because you get so much sunlight, you generally have warm, rising, moist air with a lot of rainfall. And then a little bit more north or south, you have high pressure systems where that cool, dry air falls back down to the Earth's surface, creating more desert or Mediterranean-like conditions. We can see those different atmospheres and climates throughout Earth's biosphere. So the last thing I want to talk about is winds and fronts. So this is a series of different air masses moving, the high and low pressure systems. And because air doesn't have a physical boundary, what one air system does will affect another air system, sort of like making salad dressing. You pour the oil and vinegar, it's going to move and displace each other or mix together. So warm surface air causes air to rise. We know that. You can make a balloon warmer or fill it with helium and it's going to rise. And cold air, because it has higher pressure, descends and moves outwards. We sort of are creating a three-dimensional conveyor belt. Now, at the surface, the movement of these air masses is what we feel as wind. Wind is either going to be moving away from high-pressure systems or moving towards low-pressure systems. It's going to be the physical air that we can feel moving towards those locations where there's a lot of suction going upwards or a lot of force going downwards. Now, where those different air masses, maybe cool, dense air or warm, moist, rising air connect is what we call a front. And based on the movement of those different air masses, the strength of those air masses and the pressure differences in the wind, we're then going to have very different weather patterns resulting from those fronts. We can have a cold front which displaces warm air, or we can have a warm front that is slowly displacing cold air as a result of the movement of the air masses and the wind speed. This video here is going to show and describe how cold and warm air moves and how those two fronts interact to create very different weather patterns. So, what does this mean for the forecast that we saw? Right now it's snowing out, and it's probably the result of some low pressure that we see in Vermont. Generally, low pressure systems have air rising, which will cool and condense and form precipitation. So it's no mystery that along these different low pressure systems that we have a lot of precipitation as a result of that. Now we see over in the Midwest a large system of high pressure. That high pressure is moving towards New England and it's going to be displacing this low pressure system. What does that mean for our forecast in the next couple days? Well, we're going to see pressure in the atmosphere likely rising, and with that, some nice weather as a result of that cool, dry air coming back down to the surface and warming, but not having a lot of moisture. So I hope this was informative. We're going to be learning more about this next week, but hopefully you understand the basic premise of low and high pressure, cold and warm fronts, and how those things influence the weather.